Hello there, Mr. Sutton here, bringing you the Algebra 2 11.3 Part 2 homework solutions on geometric sequences and series. This problem, we're trying to find a rule for the nth term of this geometric sequence, and we're given two non-consecutive terms, so we're going to have to deal with that. In order to write my nth term formula out, I'm going to need the first term and the r value. The easiest thing to find first is going to be that r value. So to do that, I'm going to take a root of 256 divided by 16, and I'm going to have to do the 5 minus 3 root of that. So all of this. So basically dividing these and then figuring out what I have to multiply by each time to get from 16 to 256. So that's going to be the second root or square root of, this will just be 16. So square root of 16, that's actually pretty easy. That's going to be 4. And we're just going to use a positive value for this. So let's see here. We need to figure the a1 value out now. Let me write out my general formula. a1 times r to the n minus 1. So to get the a1, we're going to plug the 4 that we just found in for the r. And we're also going to plug in one of these terms for a sub n and then use its index for n. I'm going to use the first term. That looks a little bit easier to deal with. So for a sub n, I'm going to use 16. a1 we're looking for. R is 4. And n then is going to be the 2 that goes with the a3. Or I'm sorry, it's going to be the 3 that goes with the a3 that gave us the 16. After I subtract 1 from that, though, it's going to be 2. So 4 squared is 16. So we have 16a1 equals 16. So then a1 just equals 1. Okay. And then plugging that back in, we have a sub n equals 1 times 4 to the n minus 1. In order to find the nth term formula for this geometric sequence, I'm going to start by getting the r value. Since these terms are not right next to each other, I'm going to use my a sub n over a n to the m minus n root kind of formula. So I'm going to do the 5 minus 2 root of 3/4 divided by negative 48, all of this. So this is going to be the cube root of something. I don't know what 3/4 divided by negative 48 is, but I'm going to be using a calculator at some point anyway, probably, so let me just figure that out on there. So let me do a fraction, and then in the numerator I have 3/4. In the denominator, negative 48. And let me turn this into a fraction. Press that button. That is negative 1 over 64. Much better. So cube root of negative 1 over 64. And that is going to be negative 4, because negative 4 to the third, or actually negative 1/4, because negative 1/4 to the third gives me negative 1 over 64. To get the a1 value now, because I'm going to need it to fill out this formula here, a1 r to the n minus 1. To get a1, I'm going to plug in this negative 1/4 for r, along with one of these terms for a sub n and n. For a sub n, I'm going to use negative 48. That seems a little bit nicer to work with than this 3/4 here. And then a1 I'm still looking for. R is negative 1 over 4. And for the n value, I'm going to plug in the 2. That was the index of the term negative 48. So 2 minus 1. So 2 minus 1 is just 1, so that's kind of nice. I just have negative 1/4 a1 times negative 48. To get a1, I have to multiply both sides by negative 4. Negative 4 times 48, I believe, is going to be 192. So that's my a1. Plugging that back in, we're going to have 192 times the r value, negative 1/4, raised to the n minus 1. For this problem, I want the nth term of this geometric sequence. Since these are not consecutive, I'm going to go ahead and use my root formula. So I'm going to have the 5 minus 1 root of negative 486 divided by negative 6. So we divide the terms and subtract the indices to get the radical that we're going to use on this. And this will give us the r value. Negative 486 over negative 6. Well, 480 over 6 would be, what would that be? That would be 80. So 486 over 6 is 81. Oh, well, that's convenient. So this is the fourth root of 81. What do I need to raise to the fourth power to get 81? 3. And I could find this on Desmos, but I mean, that one I've got. All right, so I need to get the a1 value now because I'm trying to complete the formula a1 times r to the n minus 1. This is my general geometric nth term formula. So I'm going to plug in the r along with one of these points to get everything filled in except the a1. Now, in terms of which point I'm going to use, this is kind of a no-brainer. Let me use this -6 right here. That one's pretty easy, and it has an index of 1, which makes my life even easier. So for a sub n, I'm going to use -6. a1 we're still looking for. R we just found, that was 3. And then we're using 1, this index here, for n. So that gives us an exponent of 1 minus 1, or 0, which means 3 to the 0 is just going to be 1. So that just means a1 then is -6. Oh, wait a second. We actually already had a1 this whole time. I guess we didn't need to do all this reverse lookup work. Oh well, we're here now. So plugging that back in, we've got -6 times 3 to the n minus 1, and we're done. For this problem, we're trying to find the sum of this series. Since I have a something being raised to an exponential function here, since my index is in the exponent, that means this is a geometric series. So I can use my geometric sum formula. That was a1 times 1 minus r to the n over 1 minus r. So let me figure out all my different parameters here. The n, that's the number of terms. Since we're starting at 1 and the upper limit is 9, 9 is going to be my n. And next for the a1, I have to plug 1 into this expression in the summand to get that. So 5 times -2 to the 1 minus 1. That's just -2 to the 0, which is just 1. So this all comes out to 5 times 1, or just simply 5. And now the r value, that's what I keep multiplying by over and over again in this expression. And that's this -2 for my base. Okay, let's plug all that in. So we have the a value 5 up here. And this will actually be s of 10. There we go. So we've got 5, and then we've got 1 minus, this is going to be the r value -2 raised to the n value 9. And down here we have 1 minus the r value -2, so that would be 1 plus 2. And I'm just going to plug all this into Desmos. So let me do a fraction. We got 5, and then we've got 1 minus -2 in parentheses, exponent of 9, close the parentheses, and then denominator we've got 1 plus 2, which all this comes out to 855. For this problem, trying to find the sum of this series, since I have an exponential term in here, this makes this exponential pattern, which means it's a geometric series. So I'm going to use my geometric sum formula. a1 times 1 minus r to the n over 1 minus r. So let me find the different pieces of this and plug it all in. For my n value, the number of terms, we're starting at term 1 and ending at 10, so that's a total of 10 terms right there. For the a sub 1, we just have to plug the first index, which is 1 in this case, in for I in the summand. So we've got 4 times 3/4 to the 1 minus 1. 3/4 to the 0 is just going to be 1, so we have 4 times 1, so 4. And then for the r value, that's what I keep multiplying by in this expression. That's the 3/4, that's the growth factor here. So putting all this together, we're doing the sum of the first 10 terms. We have the a1 of 4. We've got 1 minus the r of 3/4 raised to the 10th power. And we have 1 minus the r value 3/4. Definitely plugging this into the calculator. So putting all this together, let me make a fraction. We've got a 4, parentheses, 1 minus, and then I'll do another little parentheses here. 3 divided by 4 in there, close that. We need an exponent of 10, and then close that whole parentheses. Go down to the denominator, we have 1 minus 3/4, and this all comes out apparently to 15 0.099, which I'll just round it to 3 decimal places. For this problem, you share a link for a movie trailer in a chat. 3 of your friends repost the link, then 3 of each of their friends repost the link, and so on. We want to find the total number of people who reposted the link after the 6th round. All right, so since we keep multiplying by 3 over and over again, every single round, it's 3 times the previous number of people who have reposted the link. That means this is a geometric sequence, which means adding all these rounds together is a geometric series. So I'll use my geometric series sum formula. So that's a1 times 1 minus r to the n over 1 minus r. And let me just get the different parts of this so I can put it all together in the calculator. The n is the number of rounds here. That's 6. And then for the first term, that's the number of people who reposted during round 1. That was the 3 of your friends who initially reposted it, so 3 for a sub 1. And then for the r value, that's the number of their friends that keep reposting it every single round. That's what we're multiplying by each round. So that's going to be 3. Putting all that together, the sum of the first 6 rounds, we have our a1 of 3, 1 minus the r of 3 raised to the 6th power, all over 1 minus the r value 3. And let me just go ahead and put that in my calculator now. And I'll just clear out whatever's in there. So fraction 3 and 1 minus 3 to the 6th. All of that over 1 minus 3. And that comes out to 1,092 people who have reposted this thing. For this problem, we can calculate the monthly payment, M, for a loan using this formula down here. L is the loan amount, I is the monthly interest rate, and T is the term of the loan expressed in months. Now let's say we're buying a used car. We take out a 5-year loan for $15,000 and an annual interest rate of 4%. We want the monthly payment. All right, well, let's start plugging things into this formula. So the loan amount is $15,000, so that's pretty straightforward. And we have the summation from k equals 1 to t. T, the term of our loan, is 5 years, but this term is expressed in months. So to get a t value, I actually need to do 12 times 5, and that's actually going to be 60 up there. And then we've got 1 over 1 plus the interest rate, but we got to be careful here too. They gave us the annual interest rate of 4%, but this I value is actually a monthly interest rate in decimal form. So I'm going to do 0.04 divided by 12 for my I value. And then I'm going to raise this whole thing to the k power. All right, let me go to Desmos Grapher and plug all this in. So we have 15,000 divided by summation, so SUM. We're going from, we can't change the n, but we've got 1 down here to 60. And then in here I've got parentheses 1 divided by, and I've got a bunch of stuff in my denominator. We have 1 plus, and now I need to do 0.04 itself divided by 12. So I got a fraction in a fraction. I'm glad I'm using the Desmos Grapher here because that's kind of gnarly. So close that whole parentheses, raise that to the, I'll have to use the n power because of the index needing to match here, not the k. So that all comes out to $276.25.